happen to be an alumni of IIT Bombay. I mean, those areas, these are the institutes which started 3D printing also very early on. They got probably India's first 3D printers, to IIT Kanpur, IIT Bombay, and IISc. And in fact, I was running a mission in my alma mater, IISc, in the year 2000. And so it was a kind of a hands-on. I never realized that, I'll be again working on this in a greater depth, So, I mean, this is what we call it a destiny. And many times I keep, if I were to recollect my earlier talks, I used to also tell people that this is the future technology and this is going to replace all manufacturing. But after having, gone through this for 20 years now with this technology, I can see that this is a kind of not a revolution, but a evolution. From 86 to today, 2021, we have passed 35 years. 35 years is such a long time. Almost 1/3 of a century is passed, and people are still talking about the technology. So there must be something right or wrong with this technology. Probably that's what I'm going to talk in my next talk. So let me not go deep into it. But today we'll stick to the past, present, and future. Well, most of the things what I use in my slide, they're all, it belongs to various people, IPs. What we own is our narrative and its organization. And, the whole world, what we see today, they're all made up. It is a built world, we call. So human beings have brought something called as the artificial. Artificial means one which is not natural. Correct, no? Can I request somebody to mute themselves? There's someone who is on live disturbing me.
Yes, Mr. Professor Ranjit Patil, please mute. Ranjit Patil, Professor Ranjit Patil, please mute your mic. Professor Ranjit Patil or Kashmiri, you can have the right to mute the participant, please mute it. Yeah. Okay,
Thank you,
sir, done.
So we were at, how human race have come trying to build, trying to not adjusting with the nature, but modifying nature. They could have, like birds and animals, they could have stayed, in the nature without building anything. Of course, when it is raining, like right now, it is raining outside, heavily in Bombay. People used to go under the tree or get into a cave, naturally occurring things. But they felt it is not adequate. There are not too many caves, not too many. Probably they had a lot of trees, but that is dangerous because animals are going to come and kill them. So they needed many things. So the human kind, has started modifying the world. Today's topic, very interestingly, they say 3D printing and design. Now, why design has been added to 3D printing? Very interesting, isn't it? Because without design, you can do nothing about it. You cannot print anything without design. And design also, what design you are going to do? Design has to address a problem, a problem which is burning, meaning prioritized. You may have 10 problems, but you elect and select one problem and you focus on it and you solve that problem. Next comes the next in the priority, right now. So design is a problem solving activity And very interestingly, the organizers have added this 3D printing and design. And we'll come back to this again and again. Uh, this session would repeatedly stress about the role of design, because at the end of the day, manufacturing will be taken for granted. Believe me, the world, whatever you see, the progress comes from design, not from the manufacturing, because it will be taken for granted. Somebody will do something somewhere, and who bothers, right? Today, right now, for world, they thought so. They gave it everything to China. You design at your own countries, you give it to China, they will make it. It is a least value added or value adding activity. If you look at the spike curve, manufacturing is the least value added activity. What is most value added? It is the branding, design, research, IP, all that. On the other side, logistics, networking, owning customer relationship, and all that. Manufacturing, the treasury of manufacturing, making things, managing supply chain, all that, is going to be dumped. Probably, that's what America did. That's what Europe did. But the nature has a way to play the balance. The nature gave world a new challenge. The COVID, right? When the COVID was brought, it took everyone by surprise. The supply chains, global supply chains got cut. Now Europe is looking at becoming self-sufficient. America is becoming their own self-sufficiency they need to achieve. Though China is still supplying, people have realized depending on one country alone as a world's factory can be dangerous after all. In India also, we have been, going for self-reliance. Of course, it's always there, but now with a enhanced, underlining of Atma Nirbharata, the challenge taken up by the PM and the government, people are trying to see how best. And many countries have actually stopped working with China. They are shifting to India. Not only India, whoever. It can go to Bangladesh, it can go to Sri Lanka, it can go to Vietnam, it can go to... So there is a kind of a competition now in the... so there is a shift in the geopolitical situation. And so that is a kind of a foundation, art of making things. I'm going to zoom you into prehistoric time. The humans actually had no written communication, Language was not born. They were only imitating animals, probably. The birds. And they hunted. And they kept a record of it in the caves. They were still not ready to build houses, So they were more like animals, but little better, because birds don't keep record, animals don't keep record, and human beings did. So that is beauty. So you have the manifestation of that in many caves, and this is one of them, one of the early scenes. So after the kill, they ate food. After they're happy with the filled stomach, they started writing whatever they saw. That has become a kind of a record. So this is one of the early records of human record keeping. And, people started to protect themselves. And human hands are kind of lousy. They don't have any long nails or claws or paws or whatever you call. We had to depend on something durable. You can see the beauty of how they adopted stone. The stones in the riverbed, they were rolling and becoming round. The round cannot be used to cut. It can grind on one side. On the other side, they kept it round so that they can have a bearing area on their hand. See the beauty. The design Design was managing the world. Design is nothing but coping with over the world, the circumstances, the context, and staying fit and to survive. All this is to survive. And they made so many of them. They also had great knowledge about using a kind of a wooden stack or stick or branch as a mechanical advantage, a lever, without knowing actually the principles of mechanics and all. They were able to have, because they were able to safely, without their hands getting hurt. They extended their hand by a wooden stick, and they tied those stones, and they were able to do a better kill. So this civilization of humans happened after a long time. This is an evolution. And in fact, the other record keeping, time is something, or counting and accounting. You can see this is a bone on which they have made some marks. People decipher this as some kind of early counting human beings started. That's very important, because we are talking about Industry 4.0 today. Computing, the mathematical things are now automated. The counting has become automated with the use of computers. So it's very important to get back to these roots where we started. And also, you can see the artifact from the top row to bottom, the top row left to bottom row right, far right. You see the artifacts having themselves a kind of evolution. The utilitarian things started appearing much later, and the decorations, the treatment, the finish, the finish, all these are something which are learned over a period of time. And today we are trying to actually look at asteroids. We are looking at moon. We are looking at Mars and beyond. People are even thinking of space travel, so much so they have gone and come, had a kind of public getting exposure to space, beyond astronauts. And people are also looking at building colonies. And probably today's technology, the 3D printing, is one of the most versatile technologies that can go into space, and also not only space, but to the heavenly bodies, like probably Titan, the Saturn satellite, which has got Earth-like conditions. It has got a blue sky, and we don't know what all there inside. But it is very close to a very big, giant, poisonous planet, Saturn, and it is very, very cold there, right? But before that, they need to leap to moon and to the Mars. So, in fact, one has to travel almost at the speed of light to reach these places quickly. While it is impossible to fly at the speed of light because of various physics and related issues we have. But additive manufacturing is enabling humans to explore these long distance travel, because they're able to make things lighter. They're able to make exotic material in a most optimum way, that 3D printing can give. Well, you can see how people have progressed through the ages, making so many artifacts. So if we look at the early artifact to one which is recent, that is also 1500 BC, you can see they're not too different. They're not too different. Even today, what we use is not too different. Probably the rice they grew years back probably was more healthier than what we do today with chemical and other things. So that's why people are moving towards the organic things and all. But interestingly, the 1500 BC artifact on the right hand side has motifs which are repeated, you know. So they were able to divide a circle. So not only they knew how to make this, but also they were able to divide it. And many have recorded many things on these, you know. And so we are actually talking about art of making things now, and the clay which was easily available, they could do many things. Along with the clay, they also got many other things, shining objects. These shining objects are nothing but metal. It could be gold, it could be copper, any other, you know, naturally occurring metal, separated from the metamorphosis rock. They also got tumbled in the rivers. They flew down the river, and the Bronze Age was marked. They soon discovered these are better tools, so they were able to make very, very fine tools, needles and all. And you can just see what all people have done in the Bronze Age. Beautiful, isn't it? They had so many ways to do it. The lost wax process was already known to them, you know, and so much so, even today we use it. And of course, with the iron, which is a harder material, people were able to actually make good iron in India. And that's why in India you find lot of stone temples. And not only that, the woods steel from Tamil Nadu, that area, it went all over the world, particularly to the Damascus and Jerusalem and Greece and all that, you know. So it was a tool material. So we were the pioneers in that, and it is a low carbon steel, giving it a cutting edge, you know. And even today, people are exploring and going beyond that, you know. HSS, high speed steel and all, how they have. We study great deal about steel, the iron carbide diagram, and the mar edging steel has become a great material today for tool making, and that is being explored in 3D printing. You know, mar edging, you know, martensitic and aging. They combine the word, you know, these two, martensite and aging, mar aging steel, and they have been doing wonderful experiments on that front. But you can see some of these manifestations in the wonderful stone sculptures people see across the world. You know, even in the Mohenjo-daro time, there you can see, and till recently, during the Kakatiya period also, we see in the later on Vijayanagar period also, many things in Mount Abu and many places, you know, we see a lot of such artifacts being done because they had the working knowledge with a strong material which can cut. So if we want to sum up, they started with what they could shape easily, clay, by their own hands, and then it started taking different forms. You know, people had pinching method. People had putting a ring over the one above the other and smudging them together to make a pot, or it could be potter's wheel. You know, and this is something which we see even today. The technology probably which is 30,000, 40,000 or 50,000 years ago. Nobody knows, you know, because people are able to find every day new findings of pottery being unearthed, you know, and we don't know, you know, we went to high school and we read all this. What is happening today in archaeology and all are throwing lights that these are all very old, older than what we thought. There are some crafts which even today we use hands, like this basket. And in the early days, there was only crafted things. The markets, what we find, They were very similar to what we see. And human beings, whatever they had around the surrounding them, they started making use of them, in order to keep themselves warm, in order to protect themselves from the sun or wind. They started making many things, and so the making is something which is purely for the survival, purpose. Later on, when they could cope up with many things, they started a cottage industry. But the cottage industry is something at one's home is not very disciplined. So this is what they did, and they gave it to the weekly market. And you can see there is no consistency of artifacts here. They could make many things, but not one thing which is, millions. They could not do it, you know. And consistency was a problem. Quality was a problem. But there were a lot of always master craftsmen who could actually do very well, and others learned from it. So there was a kind of a early university of skills, like what we have now, skill sector council and all. So they were the guild, art craft guilds were there all over the world, and they were making it for their own local consumption. Even the transaction was a barter system. There's no currency or coin or whatever, And much later, it all changed, isn't it? And so people in the early 17th or late 17th century, the factory was born, where people, the craft guilds, they kind of closed down, and they said, okay, we'll give you a small place where all of you come and do your work. So this was also kind of a forerunner to Ford's line system, production line, and also a division of labor. Here division of labor is not seen, but you can see people are working on their hands, in their hands, and they have supervisors who take care of their needs, raw material supply and all that. If they need anything, they are just a facilitators there. So this is the early, image of a factory without any kind of machinery, mechanization, or such things. But soon they had to improve it. The mechanization started, just like how the early humans used a wooden stick to increase mechanical advantage of stone. Many of these principles were put together to make things, to do many things. We all know this. And then, of course, the Industrial Revolution was born. It was born because of one, people who wanted to make a lot of money on one side, the capitalism or whatever you call it. The other side, there's a need, there's a demand, and the supply. Supply was not there, demand was there. So by then, the world was actually having a lot of population also, because humans could survive, and they were able to cope with the hardships of the nature. And so population kind of, it was not in check. So people needed more things to be produced. And so the concept of industrial revolution, where large factories using mechanized equipment, and using a kind of a giant energy, not just horses, but many 1,000 horsepowers they wanted to have. They soon, with the steam engine, they were able to have a prime mover which will move everything, right? That same thing, it transformed to the fossil fuel and the electrical energy, and what we see today. So this is one of the early photographs. Probably Bombay used to look like this, with a lot of mills, and you can just imagine, it would be very dirty, polluted. So the pollution started, the carbon footprint, so-called, warming the globe. This looks like a cattle shed. This is the first production line of Henry Ford, one side the chassis will enter, the other side will leave with four wheels. Each one adds something. So division of labor was born, production line was born, and well, today also it remains very much like this, only with a lot of sophistication, less people, more robots have come, and so we are heading towards Industry 4.0. In fact, with the advent of electromechanical devices, the valve radio, valves, transistors actually brought the miniaturization, and later on, there's no looking back. The computation started taking shape. You know, NCs became CNCs, normal machines became NCs became CNCs, and automation started. And so we call that as industry 3.0. We'll see that later on. So the modern name of art of making things was given by engineering discipline as production technology. So if we look at production technology, predominantly there are three areas by which we can produce anything in this world. One is subtractive way, additive way, and formative way. Why I want to stress here is, as a practitioner, I want to tell you some truth. Okay, many times we call 3D printing as additive. Why it is additive? And additive manufacturing also we say. So I would like to a little bit bust myths on this, by showing you this. So if you look at the manufacturing process, we have something called as a plus process. We have something called zero or forming process, and something called as minus or subtractive process. What is this plus additive processes? They are casting, welding, cladding, painting, plating, gluing, lamination, coating, and 3D printing. So I would like to draw your attention to this fact. Under the manufacturing umbrella, which is a larger one, you have plus process, zero process, and minus process. Under plus, the additive processes, we have so many, of which 3D printing is a subset. This is very important. This realization is because I have been practicing this. So people have coined additive manufacturing. But what is manufacturing? Manufacturing means making millions. Okay. But as a practitioner, I don't see 3D printing be used today to make millions. I don't think there is an intention to make millions in future also. Because that is not viable for me. Why should I do it? Probably I will put some 1,000 3D printers and I can make a million. No issue. So in the world, there's so many 3D printers put together. They may produce so many millions, right? But today, in one factory, people produce. Every second, something comes and gets generated. It is ejected out every second. Cycle time. If you look at that, I don't see. Probably one day it may happen because of some disruptive technological things may come. But today, 3D printing is time consuming. Also, it is expensive, and it will take, we don't want to use it to make millions. Okay. I'll come back again, why world doesn't require 1 million in future, so that's one more thing we need to discuss. So coming to zero or forming processes, we have bending, extrusion, drawing, forming, forging, coining, rolling, knurling, embossing. Why it's called as a zero process? Zero process because we neither add something or remove something. So it is like, if I'm rolling something, a plate is going under the roller, the input weight is going to be the output weight. Maybe very small things may be lost. Wire drawing also. If I burn something, the weight will not change. If I'm doing coining or if I'm doing forging, all these things are, so we call it a zero process. Now coming to the latest or conventional manufacturing you have been very familiar with, minors are subtractive processes. What are they? The turning, shaping, milling, drilling, planing, broaching, trepanning, sawing, reaming, grinding, filing, chipping. All these. Now, I don't find the world can get rid of these three processes, the plus, minus, and zero. Why? Because each one have their own merits, you know, and it is very important. Just like what we say in operation research, some amount of X and some amount of Y I need to do to maximize my profit or minimize my time. That's what we talk about all the time. That means I need to use certain amount of additive, certain amount of zero, certain amount of subtractive in order to be viable and most effective and most optimal. Okay, we can take it as a hypothesis. We can later on prove, but I want to bring to your notice that please understand 3D printing is a part of additive processes umbrella, term. And also additive manufacturing is something which is potential is there, but today it is more, I would like to call it as digital fabrication. I think your principal referred it, the term digital fabrication. That's a very good term. As a practitioner, I would like to recommend this process as digital fabrication. I can make one. Making one is not a manufacturing, It is a crafting or it is a fabrication. So you call it as a digital fabrication, digital crafting, digital whatever. When we say even digital manufacturing, the term would be a little different. As a matter of fact, the term manufacturing was invented during the Industrial Revolution because of the capability to produce a very large volume of material and interchangeably it can be used, and the landed cost was very low. Well, so products, what we use, what we have been using, what we'll be using in future are all conceptualized first. Somebody thought about it, addressing a problem, and this is an iterative process, and we call that as a design. Why? Because whatever you do first is more like a initial thought which was there in your head, and it is taken out on a piece of paper. And when you have it on the piece of paper, you have a dialogue with that sketch, or you externalize it and show it to others, and they also add to it. And so goes the synthesis. Synthesis is like cooking, So you're cooking something, namak zyada ho gaya, kam ho gaya, you start adding and subtracting and to make it good, good for taste, right? Taste for yourself and taste for others. So iterative, because you don't get the good result in first go, because you're going to improve upon it. And this improving as a design process is universal. Whatever you designed yesterday is not relevant today, and tomorrow again whatever you design today is not relevant. So design is something which is continuously changing. Design is something which is continuously changing. That's why we say iterative process. And people today have different tastes. You have different products. You have a phone, different varieties of phone. You have anything. You take anything. You have cars, variety of cars. You take any small things also. A variety is there. Why? Because people want to improve all the time, and world has been doing that, in order to bring the products, and they kind of iterate, try out many things. If you want to make one artifact, you try to conceptualize in many ways and see how good it is. Evaluate, validate design, and this has been done not by just by sketching something, but actually physically making it. And that needed a lot of skill. And this is done by a very system approach, having a kind of a systematic technique called NPD. NPD means a new product design, and industry follows this world over. These are the days when design thinking was not yet born. Okay, we call it as design thinking today. But when I studied design, it was not called as design thinking. It was called as designing or design methodology. You know, and so going back to this, you have a lot of problems and you or opportunities or gaps. You want to address it, and so you do synthesis. You start cooking. What you start cooking? Cooking ideas, and these ideas, I also have a target. This target market, they cannot give more money. They cannot be. It has to be low cost, for example. So ideas are generated many, and they are screened, filtered off. Like for example, cost is a filter, or it could be manufacturing capability or feasibility is another screen. Likewise, they have criterias. If they fulfill, then they further go down to detailing. That is called design. What is detailing? Detailing is nothing but the embodiment design. That is nuts and bolts. What material, what thickness, who will do it, where they do it, 5W1H, all that will come in the detailing, the planning, and thereof to make in large numbers. And no design can be ever accepted just like that. You cannot build a car and think it will run. You have to check whether it runs or not. So testing becomes a very important thing. And how do you test it? Test it by actually making working prototypes. So making prototype became a kind of a very important thing. Before you can launch a product. And people have been also trying to check why one need to do prototyping. That's because the cost committed curve to the cost incurred curve are little negative, opposite or inverse. While you are doing concept design, it doesn't cost you much. Either be up canteen mein jaake you take a paper napkin and start drawing something that becomes a concept design. Correct. No? Then you go back to your lab or you have your laptop and you start putting it on a CAD. Then it becomes a detailed design. But the moment you say you want to make it, the cost is zooming, right? So world over, people are trying to check the idea whether it is good or not by a kind of validation is always done, without which they don't go further. Otherwise, they lose a lot of money, right? So you can do concept design, any number of concept designs. You can also detail if you have time, but making you need to be very careful. So you can have 20% cost, you could contain that. 80% you can save. So how this is done? People take any idea, they want to make a small prototype, they check it whether it works or not. That gives them kind of it de-risks businesses. So I can call this as a business case. Business case why people want to go for making a prototype. And in fact, in the various stages of product development, like planning, concept development, system level design, detailed design, testing and refinement, and ramp up, you have a role of prototypes being played here. And I want to draw your attention to particularly to testing and refinement. There are 3 stars here. That shows we have a higher emphasis of requirement of a prototype in the testing and refinement area. Why? So, as we learned in the morning, we should all create novel things and we should protect IP and all that. But in a large country like India with so many cases pending in the courts, having an IP and trying to protect it is very difficult. So, what companies are doing? The companies want to create number of versions. You know, so copyright is right to copy. We say, well, in a lighter vein, ironically, that copyright is right to copy. So the moment you bring a new idea into the market, it is not the customer who will say it or customer will care. He wants to use it. But the competition, the competitors, they are the ones who want to have a look at what you have launched. And if you have a problem, they can improve upon it and they can relaunch it. And they'll become success and you'll become failure. So what companies are trying to do, nobody can actually stop this copying. In some way or the other, people circumvent and they copy again. So what companies all over the world are doing, they want to develop an idea and they keep on improving it. Make a version 1, version 2, version 3, version 10. They first launch version 1. Somebody starts copying it and they will launch as version 2 because they already have it. So the company, there is no competition for them. They compete with themselves. And the companies who are copying, they are infinitely copying only. They are unable to launch anything because the market is saying a new versions. See the race of you have iPhones or smartphone from Samsung. So much competition, right? And people still don't know what to expect, but they will know something new will come every time. Correct, no? And so, what is that driving? So, the companies in their own idea kitchen, R&D, they will do testing and refinement, testing and refinement, testing and refinement. And that becomes a big business case. It will de-risk, not only of project failure, a product failure in the market, but also ensures you have a leadership, by competing with yourself. And that's why people are trying to do the prototyping. Now, what is the connection? So historically, 3D printing was called as prototyping. Why? It has got a context why it was called so. Because of the requirement of prototype, one needs a lot of skill. That skill